Makinig, manood, nasa teleradyo. Teleradyo, teleradyo Marcelo. Sa gitna ng mapanubok na panahon, magkahatid sa kakibat ay diskusyon. Sama-sama tayo, kahit magkalayo. Sa programang ito, tiyak ang pagkatuto. Teleradyo, teleradyo Marcelo. Teleradyo, teleradyo Marcelo. Teleradyo, teleradyo Marcelo.
Panginoon Diyos, maraming salamat po sa pagkakataong ibinigay ninyo sa aming lahat upang makapag-aral sa gitna ng pandemya. Salamat po sa pagbibigay ninyo sa amin ng mga taong matyagang hinuhubog ang aming isipan sa araw-araw. Gabayan ninyo po kami upang maunawaan ang mga aral na ibinibigay sa amin ng aming tagapagturo. Bigyan ninyo po kami ng talas ng isip upang matalos ang mga bagay na kailangan naming malaman. Gabayan naman po ninyo ang aming guro upang maibigay niya ng lubusan ang mga paliwanag na aming kakailanganin. Sa harap po ninyo at sa inyong bugtong na anak, inaalay po namin ang araw na ito. Amen.
Makinig, manood, nasa teleradyo. Makinig, manood, nasa teleradyo. Teleradyo, teleradyo Marcelo. Sa gitna ng mapanubok na panahon, magkahatid sa kakibat ay diskusyon. Sama-sama tayo, kahit magkalayo. Sa programa.
Hello, Delpilarians, hello! Welcome to another fun and exciting learning with me, Ma'am Queenie, on this episode of Teleradyo Marcelo, ang telearalan ng bawat Delpilarian. A quote from Alfred North Whitehead says, "It is more important that a proposition be interesting than it be true." I want to emphasize it because if we are going to think of our teaching-learning process, you, my dear learners, give a significant value to the level of interest for a certain topic, and this defines your focus and attention. As said by Whitehead, it should be interesting so that you will be able to investigate its content. So always be motivated to learn, to explore new concepts, and there will be no difficult subject or topic for you. With that, success will be within your reach. In this lesson, you will be able to understand the key concepts of propositional logic and will be able to judiciously apply logic in real-life arguments. So here are the objectives for today's discussion. At the end of this Teleradyo session, you must be able to first determine the truth values of propositions, and second, illustrate the different forms of conditional propositions. Now let us have a quick recap of our previous lesson. Last time, the topic discussed was about propositions, logical operators, and constructing of truth values. We'll put that knowledge into test. Type your answers on our comment box below, so let's start. For this activity, you have to arrange the jumbled letters to form the correct word that is being described in each sentence. Let's have the first one. It is a declarative sentence that is either true or false, but not both. So again, this is, you're going to arrange the jumbled letters to form the correct word. So type in the comment box your answer for number 1. It is a declarative sentence that is either true or false, but not both. Okay, what is this? So I'll give you a clue. The clue is it starts with letter P. So what do you think is the word? Okay, so Ray Nathaniel and Lance Estrella and Riza Canlas said it is proposition. Okay, that is correct. So proposition is a declarative sentence that is either true or false, but not both. Next, we have number 2. It is the attribute assigned to a proposition in respect of its truth or falsehood, which in classical logic has only two possible values, true or false. So again, it is the attribute assigned to a proposition in respect of its truth or falsehood, which in classical logic has only two possible values, which are true or false. Okay, number 2, Daniel said it is truth value. Okay, that is correct. Very good. Daniel, Dayao, Ray, Nathaniel, Castro. Okay, so next, let's have number 3. This is a proposition formed from simpler proposition of logical connectors or some combination of logical connectors. Again, so this is actually 2 words. It is a proposition formed from simpler proposition using logical connectors or some combination of logical connectors. What is the answer? For number 3, we have the initials C and P. 2 words, C and P. What do you think is the answer? Okay, Ray Nathaniel said it is compound proposition. Same with Kat Leoncia. Very good. That is correct. So, compound proposition, it is formed by simpler proposition that were connected by logical connectors. Okay, next. Let's have the last one. This type of proposition is always true. This type of proposition is always true. What is the answer with number 4? It starts with letter T. The answer in number 4 starts with letter T. Type in your answer in the comment box. Okay, this type of proposition is always true. Okay, so Anna Marie Joy Del Prado said it is tautology. Alright, so that is correct. Same with Ray Nathaniel. Tautology and Kat Leoncio. Very good, guys. So, excellent, my dear learners. You have understood the concept of proposition. Let's deepen your knowledge about it. So, let us have a brief discussion about it. First, we have the propositions. So, propositions in logic, these are statements that can be labeled as either true or false, but not both. So usually, just like what we had in the recap, it is in declarative sentence form. So it is usually declarative, meaning it is used to make a statement or to make statement of fact, which wish, intent, or feeling. So one example is February 25, 2021 is a Thursday. So that is a proposition because it is in declarative form. Also, another one is 12 minus 8 is equal to 4. So that is also a proposition. Next, we have truth value. So when we say truth value, it is the characteristic of a statement such that it is either true or false. Okay, so here in logic, as you all know, we use variables to represent propositions in the same way that we use variables to represent numbers in algebra. So while variables in algebra can take any values, in logic, it can only be true or false. Alright, so that's the truth value in logic. Okay, next we have here a note. A statement that is labeled as false may still have a truth value. In other words, a statement does not necessarily need to be true in order for it to have such characteristics. So again, I will repeat, the truth value can be either true or false. That is the variable that we can have here in math logic. Let's have an example for identifying the truth value of a given proposition. So suppose the proposition P and proposition R are true propositions, while Q is a false proposition. Find out the truth values of the following proposition. So for the first one, we have the conjunction of P and Q, which will be conjuncted into the proposition R. Alright, so I will show you how it is done. So as you can recall, when we say conjunction, that is the same with saying both P and Q shall exist, or both of them shall happen. So, meaning, if we're going to go back with the truth value or the truth table for the conjunction, it can only be true if both are true. So, for example, we have here P and Q, quantity R. Alright? So, in the given, it is stated that P and R are true propositions. So, let's put it here for you to visualize it. So, P and R are true, and then Q is false. Alright? So, it will be interconnected by conjunction, also known as the symbol horseshoe. So, for the first one, we have here true and false. So, we're going to combine these two. Since in conjunction, it is only true if both are true. Therefore, true and false will be equivalent to false. Alright? And then we bring down the conjunction for T. So, we have here F conjunction T. So, this is going to be another false. Meaning, this entire statement in letter A is false. So that is the true value of letter A. It is false. Next, we have letter B. Alright, so for letter B, we have a disjunction. So when we say disjunction, it's actually or, meaning it's either P happened or Q happened, but not both. Alright, so we have here P or the quantity of Q or R. Alright, so again, P and R are true. Right, these are true, and then Q is false. So in this case, recalling the truth value of a inclusive disjunction or, it is only false if both components are false. And then otherwise it is true. So again, it is only false if both components are false. So for the first one, we have F and T. So this is true because at least one is true. And then we bring down T and then the conjunction. And then true or true will give us, of course, a true answer. So the truth value for letter B is true. Alright? And then let's have letter C. So for letter C, we have a conditional statement, which is actually an if-then statement. So, if P happened, then Q will happen. So, let's write it down here. P or Q, the quantity of P or Q, and, we're having letter C. So, we have if P happened, then this set of propositions will happen. Not Q or negation of Q, or R. Alright, so again, P is true, R is true, Q is false. So let's bring down the symbols. Okay, so let's have first the negation. So we have here not F. So if it is not F, of course it is true. Then we bring down here this. And then next one is this behind this true or true. So since this is a conjunction, true or true, its true value will be true. So we have here the conditional statement if the first proposition is true, the second proposition will be true. And this gives us a truth value of true. Alright, so the truth value is true. Okay, so next we have letter D. So for letter D, we have the disjunction of P and Q and the conjunction of negation R. Alright, so P and Q. So P is true, R is false, Q is false, And then we have negation of R. Since we know that R is true, therefore, negation of R is false. Alright, so we have here this. So, true or false? We have here the disjunction of true or false. So, this is going to be true, of course. And then bring down T and F. Alright? So, again, in this junction, it will only be true if both statements are true. So, since it is a true and a false, this is false. Alright? So, this is how we determine the truth value of a given proposition. Alright, now let's have the propositions that we're going to tackle today, which is more about conditional proposition. So, I will teach you how to identify the different forms of a conditional proposition. Okay, again, conditional proposition is sometimes called an if-then proposition. So, it expresses a condition or relation of dependence between two propositions. It expresses relation and points out that one proposition necessarily follows from the other because of a definite condition. And another thing is, you have to note that a conditional proposition is the one in which two parts are joined by if, unless, we have if, unless, when, where, suppose, and in case. Alright, so it's like your hint. So to know whether the given proposition is in the form conditional, it has to use either if, unless, when, where, suppose, or in case. Alright, and of course, the conditional proposition uses the symbol, this one. Alright, arrow right. Okay, so let's have an example. Alright, suppose P and Q are propositions. From the conditional proposition P then Q, we can derive three other conditional statements. So here are the three derivatives of the conditional proposition. So these are the three forms. First, we have the converse. We have if Q happened, then P will happen. So it's like opposing this one. So if P then Q, in converse, we have if Q then P. Alright? So this is one form or one derivative of the conditional proposition. Then we have the contrapositive. We have if not Q, then not P. Alright? If not Q, then not P. So as you all know, Q is the second component, P is the first component. So if the second component did not happen, therefore the first component did not happen too. Alright, so that is a contrapositive. And last, we have the inverse, which is if it is not P, then it is not Q. Or in other words, if the first component did not happen, then the second component will not happen as well. So that is the inverse. Alright, so later on, we're going to have examples in real life so you can be able to understand it more. Alright, so what's with these three derivatives or three forms of the conditional statements is that a conditional and corresponding contrapositive are logically equivalent. And likewise, for a given conditional statement, its converse and inverse are logically equivalent as well. So, but what do we mean by logical equivalent? So when we say logical equivalent, it means that the true propositions have the same truth value. So meaning, conditional and contrapositive have the same truth value, and converse and inverse have the same truth value as well. And usually when we say logically equivalent, it is denoted by the symbol, this one. So we have, if we're going to use the proposition P and Q, we can say that P is equivalent to Q or logically equivalent to Q, or another symbol that we will most probably use more often is this one, the biconditional proposition of P then Q. Again, this is the what we call biconditional proposition, meaning if P happened, then Q will happen. At the same time, if Q happened, P will happen. So that is logically equivalent. Alright? Meaning, biconditional is referred to equivalence. Alright? So, let's have how did it happen? So let's prove how did it happen. How did we say that conditional and contrapositive are both logically equivalent, and at the same time, converse and inverse are logically equivalent as well? Alright, so let's have a truth value to show this. So again, we have the if P then Q statement. So this is the conditional statement. So we said that we claim that this is actually true, or this is actually logically equivalent to the contrapositive, which is if not Q, then not P. Alright, so we're going to prove. Alright, so we're going to prove that these are logically equivalent or biconditional by showing that they have the same truth value. Alright, so again, we have to recall the truth table for the P then Q. So this is the conditional. So P then Q, we have the two components P then Q. And then we have here if P then Q. Alright, so we just have 4 cases here. It's either the first one, it's either both are true, both are false, the first one is true, the second one is false, or the first one is false, the second one is true. So let's put it into symbols to understand it easier. Alright, so it's either both are true, or both are false, or the first one is true but the second one is false, or it's either the first one is false and the second one is true. Alright, so these are the possible cases for the if-then. Alright, if P then Q. So again, so for this one, for the conditional statement if-then, it can only be false if the second statement or the second component is false, and then otherwise it is true. So meaning, the only false here is this. The only set that gives us a false truth value is this one. If T, then F. And then the rest are true. Alright, so for us to tell whether they are equivalent, this P then Q, to this one, to its contrapositive, we have to show that this one on the right is also equal to this. So meaning they should have the same results. Okay, and that way they can be logically equivalent. Alright, so we have here negation of Q. So we write negation of Q and then negation of P. So those are the two components. And then, of course, the entire. If not Q, then not P. Okay, so if not Q, so we have here the truth values for Q here. Alright, so we're just going to negate it, meaning it's going to be the reverse of it. So instead of true, we're going to have false. Instead of false, we're going to have true. And here, another true, so it will become false. And then we have here negation of P. So for P, we have true, false, true, false. So negation of P is false, true, false, true. Okay, so, and then we're going to combine it using this logical connector, if then. So this will be false, false is true, true, true is true, true, false, again, is false, and false, true is true. Alright, so what can we say from this? We can see that they have the same. Alright, they have the same values here. Alright, so meaning they are logically equivalent because we have here TTFT and TTFT as well on the right side. So that's the proof of how the conditional statement is logically equivalent to contrapositive. Alright, and then let's have the other one. Alright, for the other one, we have, so I will just write it down. We have if Q, then P. Alright, so this is actually the converse. So we are saying that converse is logically equivalent to the inverse. Alright. So if Q then P is biconditional with the negation of P, then the negation of Q. Alright, so we have the first one first. Here on the left side, we have Q and then P. And then if Q, then P. Alright, so the same with the first example that we had, it's going to be either both are true, both are false. The first one is true, or the second one is the only true. Alright, so let's enumerate that here. Okay, so if Q then P, so again, I will just say it again and again and again. So it will only be false if the second statement is false. Alright, so meaning this is the only false here, the second one. If T then F, and then the rest are true. Alright, again, the right side shall give us the same result, TF, TT. Alright, next we have here negation of P, negation of Q, and then their conditional statement. If not P, then not Q. Alright, so let's use this one on the left side for a reference for not P. So if P has the truth value TF, TF, then this will have FT, FT. Alright, and then for the negation of Q, if we have here TTFF, we have here FFTT. Or false, false, true, true. Alright, and then we have the if-then statement. Again, it will only be false if the second statement is false. So we have here false on this part, and then the rest are true. So this gives us the values TF, TT, which is the same with what we had with the converse. Therefore, they are logically equivalent. So there. So I just showed you why it happened like that. And then what we're going to do today is we will focus on the converse, the contrapositive, and inverse of a conditional proposition. So to better grasp the idea of conditional proposition, it is better that we know how to identify its forms. So I'll give you some propositions and then let us identify its other conditional statements or its other forms or its other derivatives. So here, let's try this one. So consider the following true conditional statements. So if we have if P then Q, so our if P then Q statement or our conditional statement is if GB is in grade 11, then she is a senior high school student. Alright, so the crucial here is you have to identify which is the first component and which is the second component. In this case, since we have the first one as here, if GB is in grade 11, that is our Q. This is our statement Q, rather P. This is our P statement. And then the second one, which is she is a senior high school student. This is our Q statement. Alright, so what are we going to do is we're going to construct its converse, its contrapositive, and its inverse form. Alright, so let's have a bigger space for writing here. Alright, so again, our given is if GB is in grade 11, then she is a senior high school student. So first, its converse will be if she is a senior high student, so I will just write a senior high school SHS student, then she is in grade 11. Alright, so that's how you write the converse. So again, its original form is this. Its original form is if GB is in grade 11, then she is a senior high school student, wherein the first proposition, GB is in grade 11, will represent your first component, and then the second component is she is a senior high school student. So if we're going to write it in its converse form, or converse meaning if Q then P, then we will have if she is a senior high school student, then she is in grade 11. Alright, next, let's write its contrapositive. So for its contrapositive, it has to be in the form if not Q, then not P. If the second component did not happen, then the first component did not happen. So again, our second component is high school student. Our first component is not in grade 11. So meaning, this is going to be if GB is not a senior high school student, then she is not in grade 11. Alright? If GB is not a senior high school student, then she is not in grade 11. So this is the what we call contrapositive form of our previous statement. And for the last one, we have the inverse, which is if not P, then not Q. Meaning if the first component did not happen, then the second component will not happen as well. So we write here, if GB is not in grade 11, then she is not a senior high school student. Alright, so now let's analyze all this form. So we can say here that for the first one, for the converse, we have here, if she is a senior high school student, then she is in grade 11. So if we're going to analyze it logically, like to understand the sentence, we all know that this is not necessarily true because, well, you can be in grade 12 even if you are in senior high, right? So for this one, this is not necessarily true. If she's in senior high student, she is in grade 11. Therefore, the converse of the statement is not necessarily true. So for its contrapositive, if GB is not a senior high school student, then she is not in grade 11. Alright, so meaning, this can be true, alright? So there is like a higher probability that this can actually be true, the contrapositive. And then for the last one, we have inverse. If GB is not in grade 11, then she is not a senior high student. So again, this is not necessarily true because if you are in grade 12, basically you are also a senior high student. So what if GB is in grade 12, even if he's not in grade 11? So still he belongs to the senior high school. Alright, so again, the converse and the inverse both gave us the same truth value, which is both of them are not necessarily true. But then for the contrapositive, this is true. Alright, so again, let's go back to its original form. If GB is in grade 11, then she is a senior high school student. Of course, this is true in all cases. So therefore, from here, we can infer that this original conditional statement is logically equivalent to its contrapositive here, which is if GB is not a senior high student, then she is not in grade 11. And in the same way, since both the converse and the inverse have the same result, that both of them are not necessarily true, therefore they are logically equivalent as well, or biconditional in other words. Alright? So let's have another example. So if P, let the conditional statement P then Q be the political slogan. If there are no corrupt people, then there are no poor people. Alright, so our first component here is the if there are no corrupt people. And then the second statement is there are no poor people. So anyway, guys, we're not going against anyone in here. This is just an example. And yeah, so if there are no corrupt people, then there are no poor people. Let's state its converse, its contrapositive, and its inverse. So again, for the converse, we have if Q, then P. So we'll have the first statement, and then the then statement will be P. So our Q here is there are no poor people. Our P is there are no corrupt people. Meaning its converse will be if there are no corrupt people. If there are no poor people, that's the second statement. If there are no poor people, then there are no corrupt people. Okay, so that is the converse of the statement of if there are no corrupt people, then there are no poor people. So its converse is if there are no poor people, then there are no corrupt people. Okay? And then its contrapositive will be if not Q, then not P. So meaning, if there are no poor people, alright, so it's going to be contrapositive. So let's just omit no. So meaning the opposite will happen or the reverse. So if there are poor people, then there are the negation of P, there are corrupt people. Alright, so that is the contrapositive. If there are poor people, then there are corrupt people. Alright, and then let's have the inverse. So we have here negation of P, then negation of Q. If not P, then not Q. So meaning if there are corrupt people, so our P is the first statement. The first statement is corrupt people. Then there are poor people. Alright, so if there are corrupt people, then there are poor people. So in other words, in this lesson, you're just going to construct or state the different forms, the three forms of a conditional statement, which is in converse, in contrapositive, and in inverse. Alright, so now let's try this one. So be ready to type on the chat box because you will be participating on this. So let's have this. What are you going to do is, for the following conditional propositions that I will give you, determine the converse, the contrapositive, and the inverse. Alright, for the first one, we have this. Okay, so let's just have letter A for now. If it is consumed in large volumes, then chocolate can be harmful to one's health. So let's focus on letter A. If it is consumed on large volumes, then chocolate can be harmful to one's health. So again, so let's have this here. So if it is consumed in large volumes, then chocolate can be harmful to one's health. So our Q or our P statement is this. So this is our P. And this is our Q. Our P is, it is consumed in large volumes, and then our Q is chocolate can be harmful to one's health. Alright, so now on the chat box below, I want you to write first the converse of this one. So type the converse of this statement. So converse meaning you're just going to reverse the two, the P and Q. Alright, so I want you to do it on the comment box. Okay, so we have answers here. Russell said, if chocolate can be harmful to one's health, then it is consumed in large volume. Alright, that is actually correct. So I will not write it down because you can read it in the chat box or in the comment box. So that is correct, Russell Balastige. If chocolate can be harmful to one's health, then it is consumed in large volume. So the same with Ray Nathaniel and James Brian Dayao. Alright, so very good, guys. And then let's have the contrapositive. Alright, type in the chat box, it's contrapositive form. Contrapositive of letter A. Alright, so meaning if not Q, then not P. Or if the second proposition did not happen, the first proposition will not happen as well. Alright, if it is consumed in large volumes, then chocolate can be harmful to one's health. What is its contrapositive form? Okay, so we have here, that was really fast. So you always, your answer always comes first. Ray Nathaniel, he said, if chocolate cannot be harmful to one's health, then it is not consumed in large volumes. All right, that's correct. That is the contrapositive form. All right, if it is, I will just repeat, if chocolate cannot be harmful to one's health, then it is not consumed in large volumes. Very good, Ray, Anna Marie, Angelina, Sophia, and Maureen. Alright, so you all have the same and correct answers. Last, we have inverse. For the inverse, we have if not P, then not Q. Alright, meaning if the first component did not happen, then the second component will not happen as well. Type it in the comment box below. So if not P, then not Q. Alright, so we have here answer from Sheena Leia Francisco. So she said, if it is not consumed in large volumes, then chocolate cannot be harmful to one's health. Alright, that is correct. So if it is not consumed in large volumes, then chocolate cannot be harmful to one's health. Alright, so that is true. Okay, so great job. So there, I'm seeing a lot of answers now, but I cannot enumerate all of you. So we're on the right track. So let's have the second proposition, but before that, let us have first a short infomercial.
Oh, kayo pala yan. Ang tagal na simula nung huli ko kayo nakakwentuhan, dahil Pilarians. Teka, ano ba ginagawa ko? Nagbabasa-basa nga pala ako kasi malapit na magpasukan eh. At ang binabasa ko ay ang pahayagan ng ang malaya. Gusto ko kasing balikan ng mga naganapan ng nakaraang taon sa Marcelo. Pero alam niyo ba, kahit na ilang beses ko siyang basahin, naiintriga pa rin ako sa mga ganap sa publikasyon. Naiintriga rin ba kayo? Gusto niyo bang makibasa? Halika na! Samahan mo kong alamin at kilalanin ang isa sa mga publikasyon na meron ng ating paaralan. Ito ang Malaya, opisyal na pahayagan ng Marcelo H. Del Pilar National High School, ang tahanan ng mga mahuhusay na mag-aaral sa larangan ng akademiko, pampalakasan at pamamahayag. Ang Malaya ay isa sa mga kinikilalang pampaaralang pahayagan sa buong bansa, na nagkamit ng iba't ibang natatanging parangal sa larangang ito.
Alright, so I guess you guys now are ready for our activity. So I have here examples which you can actually practice at home. So you can just take a screenshot of this example letter B and letter C. So there, take a screenshot. So whenever she will be given the chance to perform on stage, Whitney will sing all her classic songs. Alright, so the same thing, you're going to state its converse, its contrapositive, and its inverse. And then we have here letter C. that you can practice at home. Dana studied for the exam alone if her boyfriend decided to go home early to sleep. Alright, so I guess that's bad. What if her boyfriend did not go home? Then Dana will not study. That's not cool. Alright, so let's have our activity. So activity, you have to determine the converse, the contrapositive, and the inverse of the following conditional propositions. So again, be ready guys to type your answers. Alright, so let's have this. Let's have the number 1. If Sheila will decide to enter through the front door, then she will be greeted by a large group of press people. Alright, so identify which is P, which is Q, and then type in everything. So you type everything in the comment box, the converse, the contrapositive, and then the inverse. Type all of it in the comment box. Alright, if Sheila will decide to enter through the front door, then she will be greeted by a large group of press people. Type the converse, the contrapositive, and the inverse of this statement. Alright. Okay, so I will wait for your answers for number 1. Type the converse, the contrapositive, and the inverse. If Sheila will decide to enter through the front door, then she will be greeted by a large group of press people. Okay, so let's have the first one. So according to Jasmine Villarreal, if she will not be greeted by a large group of people, then Sheila will not decide to enter through the front door. So that is for the converse statement, and that is actually correct. Alright, very good, Jasmine. And then also Maureen got it correctly. And Anna Marie. And Sean Viray. Okay, very good, guys. And then next, for the contrapositive statement, it will be, if she will not be greeted by a large group of press people, then Sheila decided to not enter through the front door. Alright, again, very good, Sean, Anna Marie, and we also have Maureen and Russell and Angelina. Alright. Next, let's have the inverse. So for the inverse, the correct answer is, if Sheila will not decide to enter through the front door, then she will not be greeted by a large group of press people. And I will check who got it correctly. We have Sean again, Anna Marie, Maureen, and then Kat, and Kiel. Alright. And then the rest of the group. Alright. Okay, let's have another one. Okay, very good, guys. You're doing really, really great. Let's have another example. This one, for your activity. If at least one student slept in class, then Lynn gave a difficult quiz to wake the student. So again, type in the comment box. It's converse, contrapositive, and inverse form. So all at the same time. Alright? If at least one student slept in class, then Lynn gave a difficult quiz to wake the students. Well, in reality, I'm not doing this. I don't give quiz to wake students if they are sleeping. I give quiz if they are yawning. So yeah, it's a surprise quiz for everyone. So if at least one student slept in class, then Lynn gave a difficult quiz to wake the students. State the converse, contrapositive, and the inverse. Alright, so we have answers from Arella and Dayanara. So they said, Lynn gave a difficult quiz to wake the students, then at least one student slept in class. Alright, so that is correct. So if Lynn gave a difficult quiz, then at least one slept in the class. The same with Drix, Karil, Shireen, and Maria Dolores. Okay, next we have contrapositive. So for the contrapositive form, wait, I will just check. Okay, so we have an answer from Sean. So Sean said, if Lynn did not give a difficult quiz to wake the students, then no students was sleeping in class. So that is correct. That is exactly its contrapositive form. So who else got it correctly? Alright, so Angela Benaventura, that's correct. And Karil, that's correct as well. Okay, so that is the contrapositive form. Same with Arella. And for the last one, we have the inverse. So according to let's have according to Russell, if no students slept in class, then Lynn did not give a difficult quiz to wake the class. So that is correct. That is the inverse form of this statement. So he got it correctly. Same with Joseph, Centeno, and Patricia. Alright, very good. Okay, and the rest as well. So it's like almost everybody is getting it correctly. Okay, so very good, dear learners. So another topic was made easy for you through this teleradyo session. Before we end our session, I will leave you your homework, and I hope to enhance more of the logical thinker person in you with this activity. Again, you will analyze the given conditional propositions, then determine the converse, contrapositive, and inverse of the following. So this is your homework, and ready your phones or laptops to capture the screenshot of the next slides. Alright, so these are for item 1, 2, 3 for page 1. And then, this is for page 4 and 5. Alright, so but do not be bothered if in case you miss this, because you will be this will be posted as well on your respective Google Classroom. So let's proceed. So before we end, you may browse your Google Classroom for more examples on today's topic. And your subject teacher will be uploading them soon. Alright, so thank you, dear learners. I feel sorry for students who participated but whose names were not mentioned. But your unending support for our program is very much appreciated. So stay tuned for more teleradyo sessions of your different core subjects in the coming days. So again, this is Mom Queenie. I express my gratitude for your active participation in today's live discussion. Thank you.
Makinig, manood, nasa teleradyo. Makinig, manood, nasa teleradyo. Teleradyo, Teleradyo Marcelo. Sa gitna ng mapanubok na panahon, magkahatid sa kakibat ay diskusyon. Sama-sama tayo, kahit magkalayo. Sa programang ito, tiyak ang pagkatuto. Teleradyo, Teleradyo Marcelo, Teleradyo, Teleradyo Marcelo, Teleradyo, Teleradyo Marcelo.